Billboard, baby, do a lip and make them dance when it come on. Everybody looking for a dance for the run on.
If you wanna ride the way with me, I know some calculus and I can teach you to derive. I had a premonition of differentiation is the best way to survive. Once you get a prime, you can start to find the characteristics of the line. If you're feeling like you need a little more explaining, then you met us at the perfect time. You want fives? We got you maybe. 7 to 0, we're debilitating. The calculate, we're optimizing. Yeah. I got you, no fight, you're my starlight. You take it, dy, dx factor it. I'm derivitating. You, no fight, you're my starlight. You need us all night. Come derive with me. I'm derivitated.
I'm one of the greatest and no debating on it.
I'm derivitated, I'm heavily educated.
Ironic, I gave them solutions, they end up hating on me.
We told Calc we love it, we've been waiting.
Been fighting hard for that 5 and I'm running thin on my patience.
Needed a way to derive, even took it back to the basics.
You see what you got me out here doing.
Might have threw me off, but can't nobody stop the grind set.
FMGX, MC prime X, derivitating, chain rule, Socrates with the girl.
Had to sharpen my pencil for all the blessings I was chasing.
If I ever derive, I'll fall into a better situation.
So catch up, bring the power to the front.
Go up and get one.
They always leave when you fail, but you derive together.
Weight of the problem on my shoulders, I kept my head up.
Now Bessie, get it. Let's go, yeah. Fives, we got you maybe. The cocky queen, you're derivitating. The calc way, we're optimizing. Yeah. You, no fight, you're my starlight. You take it, dy, dx factor it. I'm derivitating. No fight, you're my starlight. You need us all night. Come derive with me. I'm derivitated. You can calculate with me tonight. You can calculate with me tonight. Actually, let me help you to derive. Yeah. You can calculate with me tonight. You can calculate with me tonight. Actually, let me help you to derive. Yeah. You want fives? We got you maybe. My cocky queen, we're derivitating. The calc way, we're optimizing. I got you, no plight, you're my starlight. You take it, dy, dx factor it. I'm derivitating. You can calculate with me tonight. You can calculate with me tonight. Bessie, let me help you to derive. Yeah. I'm derivitating.
Hi guys, this is Anya. This is Socks. You can put socks on. Okay, so Anya wants to make Socks a bed. So she has a piece of cardboard. And she wants to see how she can maximize the volume of this cardboard bed. So she has to cut out little X by X squares in each corner so she can make a 3D box. So how do we know what size X we need to cut to make the biggest box? That is the problem. So we have made H equals X because that is how high the box will be when you put it up. Because so it's gonna fold up like that. So H is gonna be this height. A is the length of the box, and B is the width of the box, as we see here. Okay, so the total length of the cardboard box in red is 56, and the total width is 32. So how would you kind of think about this is if you're cutting out 2 X's on each side, it's 56 minus 2X for this A value, which is actually how long the box will be. Same thing for width, 32 minus 2X for the actual width of the box. Okay, so now for the problem, volume, you guys know that equation. E equals length times width times height. Okay, so V of X is the length, which we already said was 56 minus 2X, times width, which is 32 minus 2X, times the height, which is X. Yes, okay. All of that together gives you this really massive equation, 4X cubed minus 176X squared plus 1,792X. Now, for an optimization problem, we have to take the derivative. So the derivative turns to 12x squared minus 352x plus 1,792. And now we have to set that equal to 0 to optimize. And we get 2x values. And using the first derivative test, we find out one of them is a maximum and one of them is a minimum. The maximum turns out to be 6.556. So we use that number to find all the other values and scroll down. Anya has the largest volume possible when x equals 6.556. A, which is the length, ends up being 42.888. B, which is the width, ends up being 18.888. And the height is x, so it's 6.556. Yeah!
Thanks, Neve. We found the right size for Socks' new home.
Here we're going to see where f of x is increasing on the graph of f prime of x. You figure that out by seeing where f prime of x is above 0. It is above 0 from 1 to 4, so you're going to write 1 to 4, and your justification is that f prime of x is greater than 0. Same thought process for when it's decreasing. Over here, you look at where f prime of x is negative, under the x-axis. It's under the x-axis from negative 4 to 1. However, if your justification is that f prime of x is less than 0, you need to break it up because negative 3 is on 0. So you have negative 4 to negative 3, and union with negative 3 to 1, with f prime of x is less than 0. To look at your x-coordinates of the extrema, you're basically going to look at where your derivative graph is going from, is crossing the x-axis. So it crosses the x-axis at 1. You're going to look at whether it's going from, if it's going from positive to negative or negative to positive. So over here it's going from negative to positive, so that's your justification, and that means it's a relative minimum if it's going negative to positive because it's going from decreasing to increasing. Then for identifying all of your POI, you're basically going to see where your derivative graph is increasing to decreasing. So over here at negative 3 it's increasing, then it's decreasing, which means making it concave up to concave down, okay? The same thing for 3, concave up to concave down, and over here at negative 1, concave down to concave up.
This is a mean value theorem problem. It says use the MBT to find all values of c that satisfy f of x equals 3x squared plus 5 on the interval 0 to 6. So in order to use the MBT, the function has to be both continuous and differentiable, which it is. So we start by using the slope equation f of b minus f of a over b minus a, which becomes 113 minus 5 over 6, which simplifies to 18. Then you can find f prime of x using the power rule, which is 6x, and turn that into c's because you're finding a c value. So 6c equals 18, where c equals 3. This is a linear approximation problem. Given the function y equals x cubed plus 30x plus 4, approximate y of 1.2 using y of 1 and y of prime of 1. So in order to create this equation, you need y of 1, which can be substituted into the original equation, which equals 34. Then you can find y prime using the power rule, which becomes 3x squared plus 30. Then substitute 1 to find the slope for the linear approximation equation, which is 33. Then you can turn it into an equation using point slope form, which becomes y minus 34 equals 33 times x minus 1. And when you substitute 1.2 in for x, you get y equals 40.6.